We are going to add a shuttle servicing mission to the Hubble Space Telescope to the shuttle's manifest to be flown before it retires.
At about 7:35 Eastern Standard Time, Hubble entered into inertial hold safe modes. We noticed spikes on the structure current and the main bus current. We believe that this is indicative of a short circuit that occurred in the advanced camera for surveys.
ACS was inserted on Hubble in 2002. Before it died, it was the most heavily used instrument on Hubble. ACS was our best survey camera, so it was able to, for example, map the distribution of dark matter in space. No one had ever done that before. ACS was critical to our study of dark energy, surveying the galaxies out across space for exploding stars, supernovae, that would indicate how far away those galaxies were and how fast they're moving away from us.
So we were pretty far along on STIS, and then ACS failed, and that was really late in the game.
What failed is a power supply. And in fact, in the ACS, there were two power supplies, one redundant set of power supplies. So one of them failed, and they switched to the other side, and the other one then failed. So there was not much time, but it was decided to see if we could come up with a fix for it.
We leveraged what we learned on the STIS job, how to get to those components, how to remove large numbers of fasteners with fastener capture plates, how to build special tools for the astronauts to do the job.
Just getting the thing to work in this amount of time has been difficult. We're running probably 2 to 3 times faster than a typical program, getting things from concept to design to actual cutting metal and building things.
It has become one of the fortes of our program that our people are really, really good at rapid development.
Removing the card, the cards that we're taking out are very similar to the card that's being removed in the STIS repair. And in the STIS repair, they are going into where the power supply is, because that was also a power supply failure. So they're taking off 111 screws for STIS, and it's 32 for us.
We had learned an awful lot on STIS. We knew how to get to these places. We knew how to pull covers off. We knew how to pull cards out. Now the problem was, could we do it where ACS components were located?
Four guide stripes and hand tight.
These instruments were never designed to be opened up by astronauts in space, and certainly not by astronauts in space working in big, bulky spacesuits.
So we needed to make sure that what we were doing was something that could be done by an astronaut in zero gravity with this big puffy suit around them, constraining their movements. And not only that, but it's inside what's called the aft shroud of the Hubble Space Telescope. So the space is kind of confined. They have these doors that they open up and can get in. But where we're actually going in is they kind of have to reach around some of the stuff and not work right in front of their faces. The primary detector of the ACS, what's known as the wide field channel, is a CCD, just like in your digital camera, only it's 16 megapixels. So there's a box that controls that, the CEB, and that's what we're taking out. And it's probably fine. It actually is probably still working, but that's the easiest way to get in and get new power into the system. We had to design a plate that goes on top of where we're taking off the screws, sort of clips on there, and has little holes in them for the screwdriver to go through, the bit, and those are too small for the screws to pass through. And that was designed for the STIS repair, and they had a very large one with lots of different types of screws, and we were fortunate that we are, in the end, only taking out one size of screw. We're going in through the top of this box, and there are 4 circuit cards in there. We'll pull those out, and that leaves us a hole with connectors at the bottom. And those connectors are what connect to the detector and what used to supply power to it. And then we'll have a little cartridge with 4 new cards in it that will slide into that space, and that will allow us to make connections there with the new cards. But also the power now will come in from the outside through our external power supply instead of coming in from the bottom.
It's particularly important to repair ACS because it, together with the new camera, the Wide Field Camera 3, make a complementary set. They have a full set of capabilities that astronomers need in cameras operating together. It's very clear that after the servicing mission is over, astronomers will be using this combination of Wide Field Camera 3 and Advanced Camera for surveys about 2/3 of the time.